Here we have algebra 2 problem. There is an equation given over here. There is x cube positive 2x square positive 9x positive 18 equals to 0. If 3a is one root of the above equation, find the other roots. Okay, so the given equation is a cubic equation. That is its degree. That is the largest exponent of the variable x is 3. Since the degree of this equation is 3, if I solve this equation, I'll be getting 3 roots. So among the 3 roots, one root is given in the question itself. That is 3a. We have to find the other roots. Other roots means the remaining 2 roots we have to find. Actually, 3a is a complex root. Actually, it's an imaginary number, so we call this one as a complex root. So whenever we have complex root for an equation, always a complex root will occur in conjugate pairs. That is, here we have positive 3a as one of the roots of this equation. Then negative 3a must be one of the roots of the same equation, because the complex roots will always occur conjugate pairs. So now we can guess negative 3a is one of the roots of the above equation. Let me write the stuff over here. So one of the roots. Okay, now I got the 2 roots of the given equation. I need to find one more root. Okay, here I can use these 2 roots, positive 3a and negative 3a, and I can get a quadratic equation. So here you may have a question, why should I get a quadratic equation using the 2 roots over here, 3a and negative 3a? I'll tell you the reason little later. So now I'm going to get a quadratic equation with the roots 3a and negative 3a. So whenever I know 2 roots, there is a formula to get a quadratic equation. So let me write the formula, that is x square negative sum of the roots. Let me write over here, times x positive product of the roots. Let me write it, product of the roots equals to 0. This is a formula we can use to get a quadratic equation when we know the 2 roots of the quadratic equation. So x square negative sum of the roots means I have to add the 2 roots. So this 3a and negative 3a should be added. When I add them, I'm getting 3a negative 3a times x, and product of the roots means I have to multiply them. That is 3a times negative 3a equals to 0. So here 3a negative 3a will become 0. 0 times x is it will become 0 positive. So I'm taking this positive sign over here. So now I multiply this 3a and negative 3a. So here it's a positive 3a. When I multiply positive times negative, so I'm getting negative 3 times 3 is 9, and I times I is I square equals to 0. Then we get x square. Positive times negative is negative 9i square. Okay, already we know that I is an imaginary number, and we have that I square equals to negative 1. So for this I square, I can plug in negative 1 over here. Let me write it is equal to 0. So x square negative 9 times negative 1 equals to 0. X square negative 9 times negative will become positive, 9 equals to 0. So using these 2 roots, negative 3a, positive 3a and negative 3a, I got a quadratic equation, x square positive 9 equals to 0. Since this 3a and this negative 3a are the 2 roots of the given cubic equation, so the quadratic expression we have over here, x square positive 9, must be one of the factors of this polynomial we have on the left side of the given equation. So using x square positive 9 as one of the factors for this polynomial, so we should try to factor this polynomial so that easily we can solve it. So how do we have to factor this one? So to get the other factor, what we have to do is we have to divide this polynomial by this quadratic equation x square positive 9 using long division. Okay, let me do it over here. So let me take the long division. In this long division, we have to take this polynomial as dividend. That is x cube positive 2x square positive 9x positive 18. Already we know that x square positive 9 is one of the factors of this polynomial. So because we got this quadratic equation using the 2 roots of this equation, 3a and negative 3a. So now we have to take this quadratic expression x square positive 9 as a divisor. Okay, in long division, always we have to divide the first term of the dividend by the first term of the divisor. When I divide x cube by x square, I'm just getting x. So when I divide x cube by x square, I'm getting x. So now we have to write that x over here. Now we have to multiply this divisor by this x. So when I multiply this x square by x, I'm getting x cube. When I multiply this positive 9 by this x, I'm getting positive 9x that we can write over here. Okay, now what I have to do is I have to subtract the expression we have at the bottom from the expression we have at the top. So since we do subtraction, we have to multiply the expression at the bottom by negative sign. So already it's positive x cube. When I multiply by negative sign, it will become negative x cube. So when I multiply this one by negative sign, it will become negative. So here this positive x cube, negative x cube will cancel. Positive 9x, negative 9x will cancel out. So here the resulting expression is 2x square. And also we can bring this positive 18 down. Okay, now what I have to do is I have to divide the first term of the expression over here by the first term of the divisor. So here 2x square by x square. So when it's x square cancel, I'm just getting 2. And also we should not continue this process anymore because in this step we got the same exponent for the variable x in numerator and denominator. So in long division, once we get the same exponent for the variable in numerator and denominator, so we have to stop this process. So it results 2. That is, when I divide this 2x square by this x square, I have to write this 2 over here. Now what I have to do is I have to multiply the divisor over here by this positive 2. So when I multiply this x square by positive 2, I'm getting positive 2x square. And when I multiply this positive 9 by this positive 2, I'm getting positive 18. So now what I have to do is I have to subtract the expression at the bottom from the expression at the top over here. So since I do subtraction, I have to multiply the expression at the bottom by negative sign. So when I multiply this positive 2x square by negative sign, it will become negative 2x square. When I multiply this positive 18 by negative sign, it will become negative 18. So positive 2x square, negative x square will cancel. Positive 18, negative 18 will cancel. I'm getting 0 as remainder. So definitely I'll be getting 0 as remainder because already I know that this expression x square positive 9 is one of the factors of this polynomial. Since this x square positive 9 is one of the factors of this polynomial, so when I divide this polynomial by this x square positive 9, I'm getting 0. Okay, now, so what is the other factor for this polynomial, cubic polynomial? So that is nothing but the coefficient that we get in the long division, that is x positive 2. Okay, now let me write, so we have original equation x square positive, x cube positive 2x square, positive 9x positive 18 equals to 0. This is the original equation. So the two factors of this polynomial is x square positive 9 that we got it over here, and the other factor is the coefficient of the long division, which is x positive 2 equals to 0. Okay, here the product of two factors equal to 0, either the first one equal to 0 or the second one equals to 0. So like we don't have to solve the first equation x square positive 9 equals to 0. Actually we got this equation using these two roots, 3i and negative 3i. So using 3i and negative 3i as roots, we got this equation. Even if I solve this equation, again I'll be getting the same roots over here. Already we got it. So now let's solve this equation. For that we have to subtract 2 from both sides. When I do so, I'm getting x equals to negative 2. So already one of the roots is given 3i, and we got 2 more roots. The other roots are negative 3i and negative 2.